In the previous video, we spoke about the operating system managers and how the managers are helping the operating system to execute all of the tasks from start to finish. In this video, we're looking at CPU scheduling, which is how does the process manager and the CPU select which task to tackle first and which one to end with. We're going to look at algorithm, states of tasks, and so on. Any task that you click on and start with usually starts at a new state, which is your click of a mouse, so that initiates a new task. That task will move into the ready state once the process manager admits it into a queue. After that, once all permissions have been granted and the task is being processed by the CPU, we call that a running state. And once that task is completed and the memory or the RAM has been cleared, we call it a terminated state, which means that task is completed, have left the RAM. Let's look at it as an example that we worked with last time. So let's say we're working on the same task, which is playing a YouTube video. Your click of a mouse is a new task, but that task has not been completed, it's not been processed, nothing. It's just a click of a mouse. So we call it a new state. The process manager is going to administer that task and puts it in a queue. While it's in a queue, it's at a ready state, ready with all of the permissions. But it has not entered the operating system, it's not in the RAM yet, and the CPU has not started processing it yet. So it's only at a ready state. Now once it moves into the RAM and the CPU starts processing it, then we call it a running state. When that task is completed and it is leaving the memory or the RAM, then it's a terminated state. So these are the four states, the four main states of any task that you're working on. Now sometimes some interruptions happen. So if a task is already in the RAM, it's being processed by a CPU, suddenly something happens and it leaves the RAM, not terminated, it goes back into the queue again, back to the ready state. An example of this is, let's say the same task, which is playing a YouTube video. You've got the process running, all permissions are there, but suddenly internet breaks down, so you don't have connection anymore. That task moves back into the ready state until the internet is back on, and then it will move into the running state again later. But at the moment, because there is no internet, so permissions are not granted, meaning that task will have to move back into the queue. Another example is a task moving from the running state into the waiting state. Usually this happens if they're waiting for the user input or output. As an example, let's say you're trying to delete an item and you've clicked on delete, then you receive a text box that says deleting will delete all the data. So your selection of delete will permanently delete all of the data, and you've got two options, OK and cancel. So this is user input. At this point, the task has been moved from running to the waiting state, waiting for you as a user to insert your input. Now once you've selected an option, then that task moves back into the ready state, which means in the queue again, and then later on, once the RAM is cleared and once the RAM or the CPU is ready to process your task, it will move into the running state once more and complete that task for you, which is deleting the items. And this is how the CPU scheduling happens. These are the states of any task that you're running. So starting from new to ready to running and terminated. Occasionally you get some interruptions moving the task back into the ready state, and sometimes while waiting for a user input, it moves into the waiting state and then back into the ready, continuing that circle of states for any task. But we still didn't answer the question of how does a computer select which tasks to start working on first. There are different algorithms, and we call them CPU scheduling algorithms. 5 of them. One is called first come, first serve. Then you have shortest job first, round robin, priority algorithm, and multi-level queue. Starting with first come, first serve. As the words or the title indicates, whichever task comes first is completed first. So if you have 3 tasks, task 1, 2, and 3, task 1 has reached first, task 2 has reached next, and then task 3 has reached last or has been clicked last, then the processes will happen in the same order. Task 1 will be completed first, then task 2, and then task 3. If we're looking at the next type, which is the shortest job first, the shortest job among the list of tasks will be completed first and removed from the queue, and then the other processes will continue as well. So if you've got 3 tasks, as you can see here, one is taking 1 second, one's taking half a second, and one is taking 1.5 seconds. So if it's the shortest job first, then the one in the middle will be completed first, and then the 1 second will be completed next, and then the longest one will be completed last. So this is one of the ways an operating system decide which task to work on first and which to work on next, and so on. Third method is the round robin. Now for a round robin, it just allocates the same amount of time to all of the tasks in turns. So for example, let's say the allocation is 2 seconds, and these tasks have come in as, this is 1, 2, 3 when you've clicked them, but this takes 3 seconds, this one takes 2 seconds, and that one takes 4 seconds. So for a round robin of a time period of 2 seconds, it will complete this 2 seconds, leaving only 1. So if it has completed 2 seconds, it will leave you with 1 second. If this has been completed with 2 seconds, so this leaves you with 0, and then again 2 seconds, it will leave you with 2 seconds left. Now if you look at this point, you will notice that this task in the middle has been already completed. So now again, we go over another round of tasks, again with a time period of 2 seconds. So if I go with 2 seconds, in the first second, this will also be done. So if that's done, that's the second one. And then going back to this one, and then this will be the last task to be completed. Again, if we're talking about round robin gives the same amount of time for all of the tasks in order without making sure that they've completed it. So it doesn't matter if they've completed the task or not, as long as they're giving the same amount of time. So 2 seconds for each, and then start over again and give 2 seconds each, and so on. The next method is priority algorithm or priority scheduling. Basically what this does, it looks at the task with the highest priority and completes that first. So let's say you're working on a video game, but you've encountered a virus attack. Of course, the video gaming will have to go back into the queue, and the task with higher priority, which is defending your computer against that virus attack, will have to take to be processed ASAP. So looking at these tasks in the middle, one has low priority, one has medium priority, and one has high priority. If we're looking at a priority scheduling algorithm, then we will finish the high priority first, then the medium priority, and end with the lowest priority last. Now the last method of scheduling, which is a multi-level queue, tasks are classified according to their type. So there's different types of tasks. Some of them are real-time, some of them are interactive, where you put in your input to the computer, and some of them are run in the background, like downloading a software, for example, or an update. It happens in the background, you don't need to see it on your screen. So there's different types of tasks. Now usually when it goes into multi-level queue, it deals with the real-time task first. So any real-time task, one click and it's done. It is done first. So it does the real-time task first, and then it works on the interactive task. So it makes sure that it's working on getting your answers. For example, if you want to click next, it gets your answer before proceeding, or gets your answer if you're clicking OK or cancel before proceeding. And once those interactive tasks are completed, it moves to the last one, which is background tasks, and then process those at the end. And these are the 5 algorithms by which a computer or a CPU decides which task to work on first and which to work on last. Now, there are some factors or some indicators that help you identify which task will be completed first. And those are arrival time, which is what time did that task arrive. And then you have the burst time, which is how long does that task take. Give it to you as an example. So if we've got task A, B, C, D, E, these are 5 different tasks, and you've got a table of their arrival time. So task A has arrived first, and then task B, and then task C, then task D, and lastly task E has been clicked. You've also got the burst time, which is how long it takes for them to be processed. So 6 seconds, 2 seconds, 8 seconds, 3 seconds, 5 seconds, as long as the priority and type has been provided. So for example, if we're looking at a type of shortest job first, if we're looking at the shortest job, we'll have to look at the burst time. So the shortest job, which is 2 seconds, B will be done first, and then D, and then E, and then A, and then C, according to the burst time. That is if we're looking at the shortest job first. However, if we're looking at priority task first, then we will have to look at how much of a priority that task is. So if it's priority first, then we will have to go for the highest priority, which is 1. So task B will be completed first, and then task A, and then task D, then task C, and then task 5. Try it out for all of the different scheduling algorithms based on this data and try to think which process will be done first. You can pause the video while you're doing this activity. If you've completed that task, you may check your answers here. How accurate were your answers? Comment below in the comment section. If you do have any questions, you may write them below here. That is it for this lesson. I'll see you in the next one.